Hi, this is Rick for EDU Mobile. Welcome to Unit 2. Now we're going to begin to talk about making decisions in the C programming language, and there are three basic ways to make decisions in C. We have something called a ternary operator, which we'll talk about in the next slide. And then we have the if family, if else, and if else, else, and so forth. And then we have the switch statement. So here we go. The ternary operator is the simplest construct. It's really only appropriate for very simple conditions with simple results. So we have whatever the conditional expression is, followed by a question mark, and then the true result. In other words, if the condition evaluates true, and then a colon, and then the false result. If the condition is true, the true result will be returned. Otherwise, the false result will be returned. So for instance, if we have an integer a equal 1 and an integer b equal to 0, and then we set result equal to the conditional a is greater than b, if this is true, 33, if it's false, 42, then result will be 42 in this case. If a were 0 and b were 1, then it would be 33 in this case. If a and b were reversed, then 42 would result. And again, this is appropriate for simple conditions with very simple results. Now, I should mention something about true and false. There is no true and false. There is no Boolean type in C at all. So if we want the symbols true and false, we will need to define them. And the way we usually define them is we use an int or a char or something like that, some integral type, and define false to be equal to 0 and true to be equal to not false. So again, just because I'm using the symbols true, T-R-U-E, and F-A-L-S-E, they don't exist in C. Now, if takes a conditional expression in parentheses, and then it's followed optionally by a series of statements in curly braces. So here we have if a is greater than b, that's the condition to be evaluated, and it may evaluate true or false. If it is true, then a will be set equal to b and will print out limit reached. There is no else here, so there is no series of statements that executes if a is not greater than b. So if, again, a simple condition and something to execute if that condition is true. Now, if the body of the if statement, that which is within the curly braces, consists of only one statement, then we can omit the curly braces, as in this case. If a is less than b, we want to increment a. And again, the curly braces are not required if there's only one thing we're doing, if there's only one statement. If else takes both sides of the conditional expression, both the true case and the false case. So if conditional expression, we execute that case. Else, otherwise, if the conditional expression is false, we execute the else clause. Again, we can omit the curly braces if there is only one statement, but always consider the style and the readability of what you've written. So there's an example here. If a is greater than b, we want to print out a is greater than b. Else, we print out a is less than or equal to b. So those are the two cases. If else is when we want to check a number of different conditions in our decision-making construct. So if conditional expression do this, else if conditional expression do this, else if as many times as we want, and then the default clause, if all else fails, do this. So we have a expression here, if a is greater than b, print if a is greater than b, else if a is less than b, print if a is less than b, else print if a is equal to b. So we have exhausted all possible cases in this construct. Now the switch statement is really another form of if, else, if, so forth, but it's used when checking a variable for a particular value. Now, the variable we're checking has to be an integral type, a char or an int of some kind, but it cannot be a double, for instance. In this case, we assume it's an integer or a char or something, and we say case 0. Now, the case condition must be of the same type as whatever A is, or whatever we're checking in the switch. So we check for A equal to 0, that's case 0, and then we do the statements we want to execute if A is 0, and then we break. If we don't break, if A is 0, then we fall through to the next case, and so on and so forth. Break is not really a member of the switch thing. Break is a standalone statement, which means break out of the current enclosing curly brace block. So here we would break to the end of the switch statement after case 0. Case 1, if A is equal to 1, we execute some statements, and then followed by a break. The default is if all other cases are exhausted. So if A is equal to 2 in this case, or -1, or 97, the default case will be executed. And the default, because it's at the end, doesn't require a break. In C, we have many ways to express comparison between two items. We have greater than and less than, and greater than and equal to, and less than or equal to, and these are all self-explanatory. They're all binary operators. Equal means is equal to. Now watch out for this, because you will make this mistake. Everyone does. Note that this is not an equal sign. This is two equal signs. The equal sign means assign whatever's on the right of the equal sign to whatever's on the left of the equal sign. Now the equal sign, the assignment operator, is binary in C. It's not unary. It assigns, and then the evaluated value of that assignment statement is the return value, let's say, of that assignment statement. So if A equals B, evaluates just fine. What it does, it assigns A the value of B, and then it returns true if B is not equal to 0. So let's say A is 1 and B is 2. If A equals B, then A equals 2, and it will print A is equal to B, because the evaluation came out as true. This is wrong normally. Now there are some cases, some edge cases, where you might want to do this. If A equal B is the comparison between A and B, and this is usually what we want to do. So watch out for this. Not equal, or bang, exclamation point equal, means is not equal to. We also have logical operators. We have and, or, and not for logical operators. And the truth tables are shown here. Basically, both A and B must be true, or not 0, for A and B to be true. A or B must be true for A or B to be true. And not A is pretty self-explanatory. If A is false, then not A is true. If A is true, not A is false. So here's an example. We have an int A, B, and C. A is 0, B is 1, C is 2. If B is less than A, or B is less than C, and C is greater than A, do something. So and has higher precedence than or. Keep that in mind. This will not execute from right to left, as you may expect, and in this case it really doesn't matter, but in some cases it does. So and will execute before the or. So the above expression evaluates to B is less than A is not true, so that's false, or, and then parentheses, B is less than C, that's true, and C is greater than A, that's true. So true and true is true. False or true is true. So that's the evaluation for that. Keep in mind, though, that and does have greater precedence than or. Not, the unary not operator, we can reverse the logic of a conditional expression using the not. Thank you very much.